This is the grade 11 theorem where you need to prove that the center angle is double the size of the circumference angle on the same arc or the same chord. Now the other form of this theorem had the circumference angle in the opposite segment, and this one is not in the opposite segment. So the proof is very similar to the proof of the other theorem. So the construction that you need to put in is always to draw a line from C to the center of the circle. You can make it a little bit longer if you want to. And we're going to just put in some numbers here. Angle C1, C2, and angle O1 and O2. And then I'm going to start my theorem. So the first thing always is to describe whether you had a construction. So we're going to say construct CO, then required to prove that O1 equals twice C2. I'm just saying before I start what it is that I need to prove. Then I'm going to assume a few things. I'm going to say let C1 equal X and C2 equal Y. That just makes it easier to prove this theorem at the end of the day. So it is X there and Y there. Now the moment you put in a line through the center of the circle and there's other lines, then they are all radii. So that brings us to this angle also being X because it is an isosceles triangle, and we also have an isosceles triangle here between CO and OD. So if that angle there is X plus Y, then this one is X plus Y. So I'm going to work with these facts now. If I do that, I say that therefore angle A is also X, and the reason for that is I have OA equal to OC, and they are radii. Then I also have that angle D is equal to X plus Y, and very similar reason, I have OC equal to OD equal to radii, and I have indicated that I have X and Y next to each other, so this angle must also be X plus Y. Okay, so now I can say that the angle AOC, there is going to be AOC is 180 minus 2x. The reason for that is sum angles of triangle. And I have the same thing for angle DOC, so it's just this top angle of my triangle, DOC equal to 180 minus 2x plus 2y. 2x plus 2y because it's the bottom two angles that I add. Right, so I have the angle AOC and DOC, but I'm interested in getting O1. So what is the angle O1 if I have these two angles? Therefore, O1 equals, it is AOC minus DOC, and I'm going to fill in those values now. So it's 180 minus 2x there for AOC minus all of this, 180 minus 2x plus 2y. If I now simplify all of this, I get, well, the 2x's will cancel out and the 180's will cancel out, so I get that the angle O1 equals 2y. Therefore, And if it's 2y, 2y was the size of C2, y is the size of C2, therefore it is 2 times C2. And that is what was requested in this theorem. So I would just conclude by saying angle AOD equals 2 times angle ACD.